Hi guys, welcome to Geology in My Kitchen. Today we're going to be making a nice simple recipe. We're going to be making a partial melt. Now to do that we're going to freeze some milk and then we're going to start to defrost it. But we're not going to let it defrost completely, we're only going to let it defrost partially, and that's what we'll call a partial melt. So a partial melt is a mixture between solid and liquid. So I'm just going to put this milk into a coffee plunger and I'll explain why we're using a coffee plunger later in the video. We'll put some of this in here and then we're going to put it in the freezer for a couple of hours and let it freeze. So the milk is now in the freezer. We'll come back in a few hours when it's frozen solid and then we'll start the defrosting process and we'll look at how partial melting can change the composition of this milk. Okay guys, it's the next day and probably no surprise that the milk is now frozen completely solid. So I'm just going to leave it now to defrost and then we can look at how that melting process changes the composition of our milk. Okay, so our milk is now partially defrosted. So this is now a partial melt. We have a mixture of liquid and solid in here. So what we're going to do is try and separate out those liquid and solid fractions. This is exactly what happens within the earth with magmas. When you have a magma, it melts at some depth within the crust or within the mantle. So if you think of something like a granitic magma, they start forming at around about 20 kilometers of depth within the continental crust. Basaltic magmas form even deeper, so you're looking at somewhere between about 50 and 100 kilometers within the earth. So they're quite deep within the earth, and because they're deep, they have a lot of pressure on top of them. You've got a lot of rocks above them that are pushing down on that magma. So if there's any fractures within those rocks or faults, these are pathways for the fluids. So the fluids, these melts, can then move up those pathways higher up into the crust until they hit a point of neutral buoyancy. So that's what we're going to simulate here, and that's why I've been using a coffee plunger for this experiment. I'm going to put this coffee plunger in. The coffee plunger has holes. This simulates pathways through the earth, so these can be fractures or faults. And we're simply going to put some pressure down on our milk to try and separate out that liquid and solid fraction that we have here. So I've now separated that out. I'm going to pour the liquid into the glass. So it's still only melted a small amount. This milk hasn't melted fully. So this is what we would call a small fraction partial melt. We've melted it by something like 10%. You have about 10, maybe up to 20% liquid in here. The rest is still solid. So this is about a 20% partial melt. So we'll separate that out. Separate out as much of the liquid as we can, so all the magma is now draining out from our solid, the solid residue left behind. Sometimes this residue is known as the restite. So we've now drained out most of our liquid. What I'm going to do now is let this fully defrost, and then we can look at the difference in colour between this milk, this liquid fraction, and this solid residue when that melts. And there should be a difference in colour. I suspect this is a lot more water rich and this is a lot more fat rich portion of this partial melt. Okay, this milk is now fully defrosted. So this is the residue that was left over after our partial melting before. So what I'm going to do is pour that into another glass so that then we can compare them side by side with our earlier melt. This was our 20% fractional melt that we had before. So let's just pour it in, and I can see from here that this stuff is significantly more watery. It's got a much lighter, slightly pale yellow colour, whereas this looks like a much more creamier kind of milk. So what I'm going to do is put those side by side. It might not pick up so well on the camera how different they are from there, but I'll try and get a photo of these two so you can see there is quite a clear difference in colour between these two milks. And that's representing a change in composition as a result of that partial melting process that we've just been through. So I'll show a photo of those two and hopefully you can see that there is a compositional difference between the partial melt and the residue that was left behind. So we've changed this composition simply through that partial melting process.